Hey guys, something I want to discuss about today is aligning your laser. And I know most people that have Rota controllers are already familiar with the compensation that you can do for a single line. So say you draw a flat line and you want an 8-inch long line and it measures, say, 7 3/4. Well, most of us know that you can go in the Rota software, you can mark your line and tell it what the actual dimension is, and it will change it in the software, and so you end up with an 8-inch line that's actually 8 inches after you offset it. That's great, but the issue that you're going to run into is potentially your gantry is not square. So when you go to cut a rectangle that's 8 inches long, you might end up with a rhombus. And so even though your x-axis is parallel, your y-axis is parallel, you're not actually getting a true square. Your angles right here are not 90 degrees. So even though your y-axis, that's parallel, your x-axis is parallel, you end up with these angles for right here that is greater than 90 and right here less than 90. And so the most accurate way to find this out is to, if you have like a large 12-inch caliper, you can make an 8-inch square and then measure the diagonals. I guarantee on these cheap Chinese lasers what you're going to end up with is one line that's longer than the other. And so in this case, you can see the rhombus is kind of tilted like this. So what you'd end up with is this line right here is going to be longer than this one. And what happens, or what causes that, is your gantry not being square. So if we look at this laser, this isn't an OM Tech, but it works just the same way as the OM Techs. It's built very much the same way. So basically, this axis right here, this x-axis, is not parallel, or it's not perpendicular rather, to this axis. And there are some different ways that you can check it. I'm going to show you a few different ways. The easiest method that I like is I found these 90-degree squares off Amazon. I think I paid like 10 bucks a piece for them. They're actually pretty true. They're machined, and they're not machinist squares, but they're accurate for what we need to do here. And the easiest way I check it is I'll butt it up against here so it's lined up with this linear rail, and I'll bump it up against this gantry, and I'll make sure there's no air gaps here, and I'll do the same thing for the other side. And what you'll find out if your axis is way off, you're going to see something like slightly tilted, to where instead of there being no light gaps right here, you'll end up with something like that. That is assuming that this linear rail is perfectly mounted onto this gantry and it's not crooked in itself. So yes, it would be better to measure against this linear rail, touching this one, but I don't have the right equipment here to do so. And I have measured that the distance that they mounted it here is pretty much the same all the way across. I mean, it's maybe plus or minus a few thousand. So they actually did a pretty good job building it, so I can make that assumption, and I can measure off here and do a pretty good job. So anyway, so if you find out that it's crooked, pretty much all machines that you buy nowadays are going to have a way to adjust that. And so how this machine works is it has one stepper motor back here. I don't know if you can see that. That stepper motor back here is coupled to a shaft that turns a sprocket on each side, which turns the belts that drive the y-axis. And the way you adjust that is there's usually a little Allen set screw right here. So I'm not going to do it right now, but if I loosen this set screw, it will allow me to turn one side of the y-axis independent of the other. So what I do is I loosen this set screw, I put my 90-degree block over here, and if it's off, I'll then grab this set screw, or grab this shaft while this set screw is loose, and I'll just kind of tweak the gantry a little bit until I eliminate that air gap on each side and I know it's square. So that is one way of doing it. And then once you're done, just tighten it back up. You might have to do that a couple times to get everything square. A really good way, so ideally you want to measure the largest rectangle you can. So to make sure you did a good job, we're going to measure the diagonals. So right now I only have a 12-inch caliper, which limits me to around an 8-inch rectangle. And so what I'll do is I'll measure one side. I get 11.31. I'll measure the other side of my 8-inch, this is a square in this case, and I get 11.25. Okay, so we're off by a little bit. So that can be adjusted for by adjusting that shaft, and it's kind of a iteration that you have to do. A little trick that I came up with, it's a little easier, or a little more accurate, rather, if you do the entire bed at once. If you just measure a little spot right here, you're going to get a smaller number. It's going to be more difficult to kind of extrapolate that over the entire bed. So I kind of made a homemade trammel bar, as it's called, which is a piece of 1.5 inch extruded aluminum, and I used a 3/8 bolt, and what I did is I ground this down on a bench grinder to a point, put a little flat on here so I could turn it with the wrench, and it passes into a little nut right there, and when I tighten it down, it stays in place. So I have a little measuring point right here. I have another measuring point identical on the other side. And so what I'll do is I'll loosen one of these, and I can actually slide this back and forth. And I made these crosshairs on the edges of a large rectangle. So you can see on Lightburn here, I have pretty much the entire bed, and I have these little blue markers right here. And those are going to be my reference points. So what I'll do is I'll start on one, I'll line it up over here, so the point of that trammel is on the point of the circle, of the crosshair. And I don't know if you can see it, but anyway, I'm lining that up. I'll tighten that down. And so now I have my measurement of one side of that rectangle. I don't need to know the actual measurement, I just need to know that they're exactly the same. And so once I have that measurement, I'll take the other diagonal, I'll line it up with the crosshairs, and I'm going to see how far off I am. And this will give you the most accurate way of doing this. And I can see that, yeah, I'm probably off by about 50,000th. Okay? And so what I'll do then is I'll just kind of iterate back and forth with the axis. I'll loosen that screw, I'll adjust the shaft, I'll measure it again with the trammel, and I'll get it as straight as I can get it. It's never going to be perfect. These aren't totally rigid machines. They're not CNC machines. They're not $100,000, so you're never going to be perfect, but this is a heck of a lot better than just taking a wild guess. And most people don't do this to begin with. So if you ever find out that you cut something, you measure it afterwards, and you say, hey, it's way off on this dimension, it's probably because your axis isn't square. And it might have come like that from the factory, or it might have just loosened over time. And like I said, this isn't an OM Tech, but I do have an OM Tech over here, and it works the same way. So you can see that stepper motor in the middle. It's got a shaft on each side. So you can adjust one side or the other, it really doesn't matter. But you can see those shaft couplers right there. And so I'd loosen a set screw, I'd adjust the shaft, tighten it back up, and I'd try again. And so it's just kind of an iteration, but once you set it, it should be good to go for a while. Anyway, I hope that helps.